So we did now take a closer look at state and how we can change state with Angular over the last lectures. Now it is worth noting that this way of updating the state of the application and of the user interface, therefore, is just one way of doing it. And it is the way that has been around since the release of Angular 2, because it is pretty straightforward and easy to use and understand. It is, however, not the only way of changing data that should have an impact on the UI, because there is a newer, more recent mechanism available as well, which I also want to show you here. And that mechanism uses a concept called signals, which in the end are special kinds of values that tell Angular when they change. And I'll show you how to work with them, and I'll also thereafter explain why you might want to use them instead of this other mechanism I showed you before. You create such a signal value by importing the signal function from Angular core. So that's the first step. With that imported, you then create such a signal value and store it in a property of your component class component. In our case, where I want to replace this selected user property value with such a signal, I'll simply create it here on the right side of this equal sign here. You can then also pass an initial value to the signal, and here I'll pass that user object to the signal. So that initial user object, which we get with help of this random index. Now, the idea behind this signal thing here is that it's in the end a container, you could say, that contains a value like this initial dummy user here. And when you then change that value, Angular will be notified about that change. And Angular then is able to identify all the places, for example, in your templates, where that value is being used, so where that signal is being used in the end, and it's then able to update these places. And I'll show you how to read and use a signal in a template in just a second. But that's the idea behind signals in the end. You're dealing with containers that contain values and that notify Angular whenever those values change, so that Angular can then update the parts of the UI where those values are used. And that can be a very efficient updating mechanism. But I'll get back to that in just a second. So therefore, of course, the idea behind signals is that you don't just have some initial values in them, but that you can also change those values. And you can, for example, change the value of a signal by calling the set method on that signal object. So by calling this selected user set, and by then passing the new value, in this case the new dummy user, to that set method. Like this, and this line here can then be deleted. So that's how we can initialize and then update a signal. We also sometimes need to read it, though. We need to extract a value from it. For example, here where we compute the image path value. Now I'll get back to this computed value in just a second, and I'll instead start here in the user component template, where we also try to access the signal value. Because when you have such a signal, you don't access the value stored in the signal like this, but instead you have to call the signal value as a function. So by adding parentheses after the property that stores the signal. This then executes the signal's read function, which gives you the value that's currently stored in the signal. So whenever you're dealing with a property that stores a signal, you have to execute this property as a function to get the latest value from it. Now what this read here does is it tells Angular that you're trying to get the value of that signal in this specific place here, so in this template here. And Angular is therefore able to set up a subscription behind the scenes, which will make sure that this place where that signal value is used, so this template in this case, will be re-evaluated, re-rendered, and updated on the UI, you could say, whenever that signal value changes. So Angular sets up a tracking mechanism that automatically makes sure that the UI is updated whenever the underlying value changed. And that's different from the state management mechanism we had before without signals. Because there, when not using signals, Angular uses a sub-package called zone.js to create so-called zones around your components, which in the end is simply an invisible grouping mechanism set up behind the scenes by Angular, where it listens for all kinds of events that could trigger state changes, so data changes that should affect the UI. And whenever such a trigger occurs, because, for example, a user clicked a button, which would be one possible trigger, whenever that happens, Angular goes ahead and checks all the components in that zone to find out whether some data changed that now needs to be updated on the UI. So whether the UI needs to be updated in the end. That's how Angular performs that change detection without signals. And the advantage of signals is that Angular could get rid of zone.js and this zone concept. So it allows Angular to perform change detection and UI updating in a more efficient manner. That's why this signal-based change detection and state management was introduced, because this allows Angular to update the UI in a more fine-grained way, where it doesn't have to check everything for every possible event that could occur anywhere in the application. That's the idea behind signals, and that's why even though the code is a bit more verbose than the code we had before, using signals is definitely something you might want to consider when working with Angular. Now, all that being said, it's also worth noting though that this signal feature is rather new. Signals were introduced with Angular 16 and partially became stable with Angular 17. And therefore, if you're working on an older code base or simply with a team that's used to Angular as it always worked, signals might not be an option there. Which is why I showed you that other state management approach first. But that being said, I'll have a complete section about signals later in this course where we will dive way deeper into signals so that you're well prepared to work with Angular, no matter if you're in a project that is able to use signals, which do offer advantages, as I explained, or if you're working with Angular without signals. My goal with this course is to prepare you for both options and give you the knowledge you need for both options and approaches. Now here in this application, we still got a missing piece though, and that's this image path. Previously, without signals, we could create a computed value with help of such a getter. Now when using signals, this is not how you would do it. Instead, in a world with signals, you would set up such a computed value by simply adding another regular property, called ImagePath maybe, and you would then use the computed function, which is also imported from @AngularCore. And computed is a function that's meant to be used with signals, because computed then takes a function as an argument. So you pass a function to this computed function, and this function which you pass to computed, and here I'm simply using an arrow function, but you could be using a regular function as well, of course, and you also don't have to define it in line as I'm doing it here. But this function now should return the computed value, which may use a signal. So in my case here, I want to return a string, which is the combination of this fixed string, assets/users, combined with this selected user being executed because we want to read that signal value. And in that case, as explained, you always must execute it. And then I want to access the avatar property on that user object that's stored in the signal. And that is how you would compute a value when using signals. Now, why would you create a computed value based on signals like this with this computed function? Well, because when using this computed function here, Angular automatically analyzes whether you are reading some signal value inside of that function you passed to compute it. And if that's the case, Angular again sets up a subscription to that signal that's being used in there, so to the selected user signal in this case. And whenever that signal receives a new value, and only then, Angular will recompute the image path here. So it's a very efficient way of setting up a computed value because it will not be recomputed every time anything changes in this component or the overall application, but instead it will only be recomputed if one of the signals used inside of it. So in this case, if this selected user signal, which is the only signal used in there, if that changes. Now you just also have to make sure that in the template you also execute this computed property, because under the hood it also creates a signal. Just a signal that will automatically update whenever the signals it depends on, in this case the selected user, change. Angular will make sure that this is tracked automatically. But since image path therefore also is a signal, as you can also see if you hover over it, you can see the type of the value here. It's a signal. Since that's the case, you have to execute it like a function in your template because that's always how you read those signal values. And with that, if you save everything and you reload, you should have the same behavior as before in this application. You should have this updating user item here, but now implemented with help of signals, which do offer the advantage I explained before. Now, because many Angular projects do not use signals yet, or might not even be able to use signals because they're using an older Angular version, I will actually not use signals everywhere in this demo application, but instead simply use them here in the user component for now, so that you see how they could be used. But I will use that other state management approach, which I showed you before I introduced signals, for the rest of this section and application. As mentioned, there will be an entire section dedicated to signals, where we dive much deeper into signals later in the course though.